This video we'll go through standard deviation, looking at some key terms and looking at exactly what it is with some examples as well, that you can have a little go at. But ultimately, why is standard deviation important? Because as you might know, it isn't an actual stats test in itself, but it's really important to bear in mind about why we do it. And you should know from this point onwards that standard deviation is developed really from a mean of a set of results, because that mean doesn't necessarily tell you everything. I mean, let's have a little look at some sets of data. Let's say we had we were doing some measurements. It doesn't really matter what they are, but the measurements we got, there were 3 groups, and in those groups, one group measured 9.8, 10 and 10.2. The second group measured let's say 9, 10 and 11, and a third group some measurements of 6, 10 and 14. Now, looking at all of those, the next step might be to have a mean, but the mean for all of them is 10. So you come out and say, well, my average, set of results is 10. The next group, my average is 10. The next group, my average is 10. But actually, there's a bigger picture here. When we look at these, we look at the black set of results compared to the red and the purple. Now, the purple set of results, all right, the spread away from the mean is quite large compared to the black set of results. And the black set of results, you can see it's just 0.2 either side. But there's 4, whatever the measurement is, there's 4 in the purple set of results. And so actually, there's a bigger picture here at play. And if, say, they were, you're making cakes to a measurement of a certain weight, then that's going to make a massive difference. So a standard deviation basically tells us how far the spread of results is from the mean itself. All right, so it's a measure of how spread out the data is around the mean. And we might see graphs like this. And these sometimes are referred to as bell curves. And you can see here the first bell curve has got a really, sort of, if I imagine that's a mountain, it's going to be really, really steep. That's going to be A. So A is going to be really, really steep. B, not so steep. And you'll see that with our sort of low set of results there, we're closer to the mean. So for A, all of our results are close to the mean. And we could say that this one here potentially is going to be more reliable than set B. And it's the standard deviation that tells us this information. So B, all right, which has got a much larger curve there, the results are much further away from the mean. So the mean in itself doesn't tell you everything. So how do we work out the standard deviation? Well, it's using this equation here that ultimately might look really complicated. But SD, standard deviation, is equal to the square root. And what we're looking at here, this E bit here is the sum of the mean, all right, take away also the mean, take away the average mean, and then that's the square root there. And we divide that by n take away 1, with n being the population size, so the number of trials that you might have, take away 1. So if you did it 10 times, 10 take away 1 is 9. So let's have a look how this would work. So we're measuring the extension of the spring here, and the extension was measured 6 times. And it's in centimetres, so we had 36 centimetres, 31, 35, 24, 21 and 47. And so following that, we can then work out the mean. So we add them all up, and then we can divide by 6, which is 32.3. So the mean extension there is 32.3. So there's our result. And so we take away that mean from 36. So it would be 36, take away 32.3, which leaves 3.7. And then we've got 31 take away 32.3, which will be minus 1.3. And then 35 take away 32.3, which is 2.7. And then 24 take away 32.3, and so on and so forth. Now, once we've done these, we then need to square root your answers. And in doing this, we get rid of those negatives there. So 3.7 squared. So you can see doing standard deviation, it takes time. It's not an easy calculation to do. All right, 1.3 squared is 1.69. 2.7 is 7.29. It does take a while, and it's important that we double check all of our answers all the time, just to make sure we don't make a mistake, because we're dealing with a lot of numbers here, and some of these numbers, they're not easy numbers. They're going to have decimal places and all sorts. So as we've done that, the next step here, remember we said, was the sum. So it's the sum of all these square roots here. So 13.69 plus 1.69 plus 7.29 plus 68.89 plus 127.69 plus 216.09. And when we add those up, we should get 435.3. And by all means, please double check my calculations. And if they're wrong, then please leave a comment. We're all prone to mistakes. So we've added those up here. So when we work out, remember, our standard deviation, that is equal to the square root of the sum of our result, take away the mean squared, n take away 1. Now, n take away 1 here, we've got 6 trials, and so it's going to be n will be equal 6 take away 1, which equals 5. And so our n take away 1 here will be 5. So our standard deviation is going to be the square root of 435, because that's the sum of all those squares, divided by n take away 1, which is 5. Should have an answer of 9.33. Now, depending on who you're watching this with and why, whether, of course, it might be here, then you might talk a little bit about sigma if you're doing A-level physics. We might talk about another video at some stage, but the standard deviations there are really important, especially when we look at error bars. And so it's quite a complex process to go through, but you can see here this number here, for it to be more reliable, it's got to be closer to 9.3, to 0, sorry, and 9.33 is a step away from that. If we had another set of results, we could then compare those standard deviations and see which one is more reliable going forwards. I want you to have a little go at this one here. So this one here, we've measured the resistance of a wire, and we've got resistance A and resistance B, and each one with for A and B there's been 5 sets of results. So I'd like to, in a second, just pause the video. Remember, your first steps, you want to work out the mean for each. All right, and then take away the mean, all right, from your answer, and then you can square root it. Add them all up. It'd be n take away 1. There's 5 sets of results here, so 5 take away 1 is going to be 4. So n take away 1 is going to be 4. Have a go at doing that on one of your calculators. Spend your time, double check it, and then look at the spread of those results. So pause video now to have a go at doing that. What we should have seen is, when you've done the results, is something like this, where resistance wire A has a standard deviation of 25.23 and wire B is 3.16. So resistance of a YB is going to be far more reliable. It's the spread from the mean, from the average, isn't as far as wire A. So again, that's really important. The next step following this really is looking at error bars and looking at confidence tests. Now, if you're doing stats as part of a module or something, you might have heard something referred to as that sort of 95% confidence that your test was statistically significant. Now, what exactly really do we want to be looking at that? What does that actually mean? Well, that really tells us that our results are unlikely to observe by chance. Now, chance happens quite a lot in practicals. This is why it's really important to control your variables and look at your independent, dependent, and control variables. Remember, it's not for a fair test. It's so that we can be certain that our independent variable, that one variable that we have changed and altered, that's affected our results and nothing else. So we can draw error bars into our data here. Now, these could be from bar charts, but also you can do it from line graphs as well. And then when we look at these error bars, which we'll do another video on later on with some examples, but it's really important to remember that if they're overlapping, it's not likely to be significantly significant at all. And so that's when we'll do a stats test next. But one question you might be asking really here is, well, what number do we use from the error bars? Now, for it to be 95% confidence in your data, what we need to do is look at that standard deviation we have on these pages here. So it'd be 25.23, and then we just times that by 2. So it's the standard deviation times 2. So if your standard deviation was 10, you times it by 2, it's going to be 20. And then if you had a bar chart, you would, from your scale, you would go 20 above and then 20 below. Yeah. And then you'll do that for all your sets of results. Now, this was just really a whistle-stop tour going through the deviation. If you think you'd like some more examples, please let me know and I can do some more. But it's really important that we understand what standard deviation is, and ultimately that it isn't a stats test. It's the first step for a stats test. And we'll do a video on a t-test a bit later on, and that's how we can use standard deviation in that t-test and what that means. Anyway, I hope that's helped you